Yep, page 13. All right, you guys ready? Does anyone need help getting into the GeoGebra? Are you all good? Again, just go to announcements, click on the one that has today's date on it, and there should be a link in that announcement. Just click on that. Okay, so today's lesson is about solids of revolution. And so what it is that we kind of briefly talked about yesterday when we were doing cross sections, but what it is that you take a shape, just a 2D figure, so like a rectangle, a triangle, hexagon, whatever, and you rotate it around the line. As you rotate it, it forms a 3D figure. All right, so from there, we can actually take volume and surface area of those shapes. So that's why you might also want that pink sheet out. It has all those formulas on it for you. So that pink sheet that I had you guys grab has all the basic formulas. So the area formulas as well as the volume and surface area formulas for 3D figures. Up there. So now, so the first thing that we're going to do is in the notes. So first thing I want you guys to do is I want you to graph these 4 points on the graph in here. So it's 0, 0, 0, 2, 3, 2, and 3, 0. Once you graph them on your paper in GeoGebra, I want you guys to do the same thing. So it should have the 3 checked. All right, so you should have this 3 checked. So you should see a red figure. And I want you to move the points to be the same thing. So make sure you look at the points carefully. So it's 0, 0, 0, 2, 0, 3 would be about right here. And 3, 0, or 3, 2 would be here. And 3, 0 would be, if my mouse would work, there. So you're going to graph the shape on both your paper and in the applet. Now, here is the 3D version. All right, so this is the 2D, this is the 3D. And the 3D you can actually grab and look at. So if we looked at it from a 2D perspective, there's your XY plane. 3D in mathematics, you add what we call the Z axis. That's what makes things 3D. That's basically just height. All right, so what the difference between volume and area, you add height to it. So first things first, we're just going to calculate the area of this rectangle. So how do we find the area of the rectangle? What's the formula? What's the formula for area of a rectangle? Length times width. Good. Now, we don't have dimensions here, but we can easily find them. How can I find those dimensions? Using the graph. I just count them. So I have 2 on the side and 3 across. So if I do length times width, I'm doing what? Two times 3. So my area is equal to 6 units squared. So that was just the area of a 2D figure. And that makes sense if you actually count how many little squares are inside this rectangle. There are actually 6. Now, we are going to then Draw a solid formed by revolving the region around the x-axis. So what I want you to do real quick is regraph that rectangle. So regraph those same points on here. Now, what you're then going to do is, if we look back at the applet, all right, do you guys see this slider right here? This red slider. You're going to drag it all the way to the right side. And it actually rotates the figure around the x-axis for us. So, what shape do you think this is? It's a cylinder. If you move it around, that is definitely a cylinder. So if you actually look at it from this perspective, there's the rectangle. If I rotate it, as the rectangle rotates around the plane, it physically makes a cylinder. So we're going to draw that as best as we can on our paper. So you really just need to draw two circles or parts of circles. So it looks something like this. And then, so there's the cylinder. Now, we're going to then calculate the volume of the cylinder, so how much space we can fit in that cylinder. First off, what is the formula for volume of a cylinder? What does it say on your sheet? So look on that pink sheet, it's on there. Pi r squared times h. So before we can do anything, we need to identify both the radius of the circle, so the radius of the bases, and the height. So the radius, let's put back at the GeoGebra. So if I turn this so that's facing this way, so 0 is this black dot right here, and then it goes out. Goes up and down too. What do you guys think the radius of this circle is? 2. It is 2. All right, so the radius of the circle is 2. Now, let's check height. So from height, it's just how high you are from base to base. So let's say I turn it this way. It's upside down. But hold on. There we go. How high is it? It's 3. All right, it's about halfway between 2 and 4, so that has to be 3 from 0. It's up 3 units. So the height is 3. Now, where do those numbers come from? They actually come from somewhere. Where does those numbers seem familiar to you? Where did it come from? The length and width of the rectangle. So if you notice this rectangle, the width was actually the radius. So that's why I made you redraw that rectangle. Do you see how it goes from the center of the circle to the edge? That's your radius. So that radius is 2. The height is just how high, if we turned it so that it was facing right side up, how high from the both center points it is, or the distance from both center points of the bases, which is 3. So that's where it connects. So we're going to plug into this formula. So I have volume is equal to pi times 2 squared times 3. So let's do this together. What is 2 squared? 4. So I have v is equal to pi times 4 times 3. What's 4 times 3? 12. So my exact answer, if I want to leave it in terms of pi, volume is equal to 12 pi units cubed. That's the exact answer. So a lot of times with these, we leave it in terms of pi so that it's the exact answer. Now, if we want a rounded answer, all right, so let's say we rounded that. So put 12 times pi into your calculator. Make sure you use the pi key, not 3.14. So 12 times, if you hit second and then the little caret key that you use for exponents, so the blue second button and the caret key, it'll actually input pi in there for you. So let's round to the nearest, I don't know, hundredth. What would it be to the nearest hundredth? 37.7. So it could also be approximately 37.7 units cubed. So either one of these is acceptable. I'm just showing you both because on your test you may see both. I just want you to know that if pi is still in it, it just means it's written in terms of pi and they didn't actually multiply the pi in yet. It's just not a rounded answer. Now, for the next one, we are going to draw that same rectangle again. So draw those same 4 points again on the next graph. And this time we're going to rotate the region around the y-axis. So the y is going to be our rotational value. So once we graph it in GeoGebra, so we're not going to be using this one anymore because it only goes over the x-axis. So what I want you to do is unclick 3 and click 4. So uncheck 3 and then check 4. And you're going to plot those points again. Now, there is an extra dot. All you got to do is just overlap it with another dot. Okay? So I have 0, 2, 2, 3. This one is at 3. And I'm going to take this middle dot and just overlap it with the one on the x-axis. So that 5th point, you just overlap it with another point. So has everyone got it? And again, that extra point, you just got to put it on top of another one of the points, and it'll be fine. All right, so any guesses what it's going to be if we rotate around the y-axis? It's probably still going to be a cylinder. So let's see. So this time it's going on the y-axis, so it's going to go over this line. So I'm going to take that yellow slider now, and I'm going to move it all the way to the right. And lo and behold, we do have another cylinder. But it looks, what's kind of the difference this time? How's it compared to the previous one that we just did? Looks like it's wider, but height-wise it looks like it's shorter, right? So, if I go back to here and I actually drew the picture, okay, I'm going to draw it the best I can. So I'm going all the way from here. So here's my new cylinder. Now, we're going to calculate the volume of this cylinder. Again, we're still going to be using volume equals pi r squared h. All right. So, again, we need our radius and we need our height. So let's look back at the GeoGebra. If I turn the circle head on, or as close as I can to head on, what do you think the radius is? So here's the center, and here's to one side. What do you think the radius of this base is? It's definitely 3. All right. So the radius this time is 3. Now if I turn it so that the height is showing, and it's upside down. What's the height? 2. It's 2 units high. So that's what I like about this applet. It kind of actually lets you see and turn it to look in different directions so that you can actually see what's going on with it. So in other words, when it rotated around the y-axis, how did that differ from when we rotated around the x-axis? What happened with our radius and height? It did what? It flipped. It switched. So our new radius was right here. That's 3. And our new height was right here, and that was 2. So now I'm going to plug that into the formula. So volume is equal to pi times, times 3 squared times 2. So let's find the exact answer first. In other words, in terms of pi. So what's 3 squared? 9. So volume is equal to pi times 9 times 2. What's 9 times 2? 18. So the volume is equal to 18 pi units cubed. Now, go in your calculator and plug in 18 times pi and tell me what you get. So we get an approximate answer as well. It's what? 53.56.5. Does it have any other numbers? Go to the 2 decimal places. 54. So it's approximately 56.54 units cubed. So again, either one of these is acceptable for volume. Now, here's kind of the conundrum. We've essentially used the same 2 numbers in both equations, or plugged it into the same formula, same 2 numbers. But why are they different? Why did we get different volumes? What part of the formula changes things? Because multiplication is commutative. So it shouldn't matter where we flip the numbers. But what part of the formula is like, okay, nah, that ain't happening? It's the square. So the reason that the volumes are different is because of the r squared. Because as soon as you square a number, its value changes. And so even though multiplication is commutative, 3 squared is not equal to 2 squared. No matter how you slice it, it's never going to be the same thing. Any questions on that? Does the applet kind of help visualize it a lot better? Does it help you guys? Okay. All right, now let's try another one, but with a different shape. So now we're going to do 2. So we're going to graph these points first. So 0, 0, 0, 3, and 2, 0. So 0, 0, 0, 3, 2, 0. So now instead of a rectangle, we have a what? We have a triangle. Okay? And what we're going to do after you graph it on this page, go back to your applet. You're going to unclick 4 and click 1. And then graph that triangle. So I got 0, 0, 0, 3, and then 2, 0. So the triangle should look like that. So again, unclick 4, click 1. Now, any guesses before we rotate it, what shape is it going to form? Probably a cone. All right, so we're not going to rotate yet because first we got to calculate the area of this triangle. So they want the area of the triangle. What's the formula for area of a triangle? It's on your sheet. Base times height divided by 2, or 1/2 base times height. And again, your base and height's pretty straightforward. Your base is just the horizontal leg, so that's 2. Your height is the vertical leg, that's 3. It's pretty easy when it's a right triangle. So this would be A is equal to 3 times 2 divided by 2. So what's 3 times 2? 6 over 2. So the area is 3 units cubed. Not cubed, squared. Squared. Now, on the next graph, you're going to regraph those points and make that triangle again. All right. And they want us to revolve it around the x-axis. Now, we think it's going to be a cone, so let's see if we're right. So I'm going to go back to GeoGebra. Oh, never mind. This one does y-axis. So unclick 1. We can save that for later and click 2. Not 2. Click 3 again. And we're just going to move it to the points. And again, just like the last one, just make sure one of the points is on top of the other. So like this 4th point, I'm just going to put it on top of another point. There we go. My bad, I forgot that one was y-axis, not x-axis. And the way I know is because it tells me right here which axis is going to rotate over. So once you get that regraphed, take the slider and go all the way to the other side. So if I turn it, does that look like a cone? Yeah, it's a cone. If you want to see it from the side view, all right, here's the triangle. If I rotate it, it forms that cone. So we're going to draw a cone on our paper. So again, just do it the best you can. It doesn't have to be perfect. So there's your cone. It's going to look something like that. Now, we're then going to calculate the volume of this cone. So on your pink reference sheet, what do they say the formula is for volume of a cone? What does that pink reference sheet that I gave you tell you the volume of a cone, the formula is? Right, 1/3 pi r squared h. So essentially, it's the exact same thing as the formula for a cylinder. You just multiply 1/3 to it. That's the only difference between those two formulas. So once again, we need the radius and we need the height. So we need the radius of the circle base and the height of the cone. So if I look back at this picture, if I turn the circle so that the circle's facing the front, what do you guys think the radius is? It's going to be 3. It's about halfway between 4 and 2, so it has to be 3. What about the height? So if I turn it like this, It's 2. If you go from the bottom to the very tip of it, it's 2 units high. Once again, why are those familiar? Why are those measurements familiar? So why is 3 and 2? Why does that look familiar? Where have you seen it already? It's the base and height of the original triangle. So here's the radius. So that's 3. Here's the height, and that's 2. It's the base and the height of the original. I want to make that darker because it's hard to see. So we're going to take that value and put it into our formula. So volume is equal to 1/3 pi times 3 squared times 2. So we're just going to do it piece by piece. What's 3 squared? What's 3 squared? 9. So I have 1/3 pi times 9 times 2. 9 times 2? 18. So V is equal to 1/3 pi times 18. Now, if you multiply a number by 1/3, that's the same thing as doing what? Dividing by 3. Good. So in other words, what's 18 divided by 3? 6. So our volume is 6 pi units cubed. So all I did, guys, was just do the multiplication one step at a time if you want the exact answer. Another way is basically if you want to just use your calculator, put all the numbers besides pi into the calculator and multiply them, and then just slap a pi on at the end. So if you do put 6 pi in your calculator, what is that approximately? Go to 2 decimal places. Come on, guys, heads up. Come on. So 2 decimal places. What is it if you put in your calculator? Which you guys should already have calculators. What is it? It's, huh? Yeah, 2 decimal places. Yeah, just 2. No, I mean, say it.
18.84.
18.84. Good. I just didn't hear you, that's why. So, it's about 18.84 units. Now we're going to do the same thing, but around the y-axis. So first I'm going to regraph the triangle. So 3, 0, 2. Now, you should already have this one graphed in GeoGebra already because that was the one that was under number 1. So you can uncheck 3 and click 1. So this one should already be graphed. All right. So we're going to drag that slider around. And it still creates a cone. So, still creates a cone, but how's it compared to this one? What's kind of going on here? How's it compared to the red one? It's thinner, but it's also taller. Okay? So, we're going to find the volume of it, but let's draw it first. So, if I rotate around the y-axis, you can just draw it as best you can. But this would be what my cone looks like. All right, there's my cone. Still using the same formula, so volume is equal to 1/3 pi r squared h. All right. So we got to know our radius and our height. So going back to GeoGebra, if I turn this so that my circular base is looking dead at me, it will let me grab it. There it goes. How big is the radius? 2. So my radius is 2. Now the height, if I go back and I turn it so that I can see the height better, how high do you think it is? 3. Which again makes sense because here's the height, that's 3, radius 2. So I'm going to plug it in. So volume is equal to 1/3 pi times 2 squared times 3. So what's 2 squared? 4. So I have V is equal to 1/3 pi times 4 times 3. What's 4 times 3? 12. So 1/3 pi times 12. All right. Finally, what's 12 divided by 3? Or 12 times 1/3? 4. So my answer would be 4 pi units cubed. Now, if you put that in your calculator, 4 pi, what is that approximately? 12.56 units cubed. It just depends on the way they ask the question. So since they don't specify, I recommend at least doing both. When in doubt, go exact. So leave pi in it. But a lot of times if they want you to round, they'll flat out tell you to round. If not, all you do is just make sure you multiply everything besides the pi into your calculator and just slap a pi on it at the end. Now, the volumes are different, and it's for the same reason as the last. It's because of that r squared. Because once again, 2 squared is not equal to 3 squared. Because even multiplying 1/3, that wouldn't change things. But as soon as we square that r, that's what makes it different. Any questions on how to find the volume of and figure out what type of shape it would be for a solid of revolution? All right, so here's what I want you guys to do. I want you guys to try the next one on the next page on your own. And you can still use the GeoGebra if you'd like. You don't have to if you don't want to, but you can. All right. I will say for going around the x-axis, use 3. So if you're rotating around the x-axis, use 3. If you're going around the y-axis, use 1. So x-axis is 3, y-axis is 1. Where you graph your shape. So go ahead and give the next ones a shot. So I'll give you guys about 6-7 minutes. I know what I said. Don't call me out on it. I know what I said. So give it a shot. Again, if you want to use the GeoGebra, you totally can. Yeah. Yeah, because there's one more. Yeah, because um, the last one I gotta show them something different. So, because there's one thing, it's pretty much the same except for this last question, which I gotta show them what that looks like. But yeah. So everyone should be trying this problem. No, someone's out. I think it's Michael. So when he goes back, he can go. All right. Thumbs up if you're ready. Give you guys one more minute and then we're going to go over it. Okay, so let's talk. All right, so first off, I'm going to graph these 3 points. Makes like a really, really thin triangle. Okay. We're calculating the region. So once again, area is equal to base times height divided by 2. What's my base? 5. What's the height? 1. So I'm going to be doing 5 times 1 over 2. So that's 5 halves. Or you could have said 2.5 units squared. Either one of those is fine. Now, we know that if we graph this again, all right, so if I graph this again and we rotate it around the x-axis, you would get a cone that looks something like this. All right, so you get like a really, really thin cone. We're going to calculate the volume. So remember, volume is equal to 1/3 pi r squared h. That's on your sheet. What's the radius? Anyone? 1. It's right here. What's the height? 5. It's right here. So if I plug that in, I have volume is equal to 1/3 pi times 1 squared times 5. 1 squared is just 1 times 5, that's 5. So V is equal to 5 times 1/3, which is 5/3 pi units cubed. What would it be approximately? What's 5/3 times pi? So it's approximately 5.24 units cubed. How'd you guys do with that one? Okay. Did you at least set it up correctly? Okay. Sometimes there may be some issues with the calculation, but that's okay as long as you set it up correctly. Now we're going to do the same thing, but over the y-axis. So I'm going to plot this one last time. Now, since it's going over the y-axis, that means it's going this way. And I'm going to try and draw this as best I can. It's a really short cone, but it's got some junk in the trunk. All right. So, what's the radius of this one? Definitely 5. So that is right here. It's 5. What's the height? 1. Plug it in. Volume is equal to 1/3 pi times 5 squared times 1. 5 squared is 25 times 1 is 25 times 1/3 is 25 over 3. So we have 25 over 3 pi, which was approximately what? Good. Or I would say 1/8. 26.18 units cubed. All right, last thing I want to talk about, and then we're done. So, the last problem on page 16 is kind of more the same, except there's one question on here that's very different. So, first off, I just want to skip to that question because otherwise it's just going to be more the same. All right. So, here are the points that we're going to plot, and I'm going all the way to part E. So, I'm going to plot these points on part E. So, it's 0, 0, 0, 3, 5, 0, and 5, 3. So we got a rectangle. Put it up. So if I rotate, what will I make? If you rotate a rectangle, what do you get? What 3D shape? Cylinder. All right. Now, here's the difference. So far we've only been rotating over axes. All right. But this next one, it's talking about rotating over a vertical line, x5. Now, that's okay because it's, because it just may look a little bit different. So, they want x equals 5. So the line that we're rotating around is right here. So the thingy that I have you guys on, it can't do a different line besides the x and y axes. But let me show you on something else what that will look like. All right. So if we rotate the shape around that vertical line. So this is GeoGebra's actual 3D calculator. Okay. I already plotted the shape, that rectangle, which is right here. And I plotted this line. The black line is the line of rotation. Now, we know it's going to be a cylinder. So, what's going to happen is that when I rotate all the way around, where is it? So when I rotate all the way around, it creates a cylinder. But instead of it being kind of in the center point changes. So the center point is no longer the origin like we've been used to. It's actually the 0.50. That's the only thing that happens. So even though we rotated all the way around, it still gave us this. Just slightly off center. So don't be thrown by that. They ask you to rotate around another line. It's still going to be more the same. It still look like a cylinder, so it still looks something like this. This one's definitely not my best cylinder, but it'd still be a cylinder, and calculating the volume would still be exactly the same. The radius would still be 5. The height would be 3, as dictated by the rectangle. So if we calculate that volume, that's equal to pi times 5 squared times 3. So that would be 25 times 3. So the volume would be 75 pi units cubed. So don't be thrown by that. Now, let's pretend for a second. So if I go back to my 3D calculator, let's pretend for a second that this was not where the line was. Let's say it was x equals -1. All right. So I'm going to change the line to be x equals -1. So from here to here. All right. X equals -1. There we go. Now, if we rotate around this line, notice how there's some space in between the rectangle and the axes. What do you think is going to happen? So if I rotate around, but there's a gap, what do you think is going to happen? It'll leave the gap in there. So in other words, it'll create a hole. All right. So think about it this way. If I rotated this, so if I made the cylinder, all right, it'd be from here. Nope. So it'd be from here to here. No. So it'd be from here to here. And the radius would be so that is without the hole. But we have to account for that middle cylinder. So if I put another cylinder in there, so that would be from here to here. It would be on the inside. So if I turn it, let's change the color here so you guys can see it easier. If I turn it, that is not where I wanted it to go. So there's the cylinder, and I wanted the other one to be here. There it is. So if I turn it, so look, do you guys see that middle cylinder on the inside right here? That would be where the hole is. That cylinder would be gone. And we'll talk more about how you calculate that tomorrow. But I just want to kind of tease that for you. Okay, so you do have a new quizzes and Delta Math. I think the Delta Math is really short. The quizzes is about the same as the last couple ones. So you guys got a solid 20-ish minutes. I expect you to be working on that. No. I'm not sending anyone to construction anymore. Yeah, go ahead. Probably. You are coming back, right? Do you know what's going on with Jersey? I haven't seen her in a couple days. So she was okay.
They said they popped one of her veins in her arm, and they said she had her hands ruptured ulcer, Or whenever she had a chair in her orphans.
Yeesh.
Wow. And she's gonna be back tomorrow. She probably has. I know. I know. And she was puking all.
Well,
I was gonna.
just let her know because she has to make up that Unit 6 test book grades are due today. I'm just going to give her an incomplete, and then she should just make it up and I'll change the grade.
I don't think she cares. Okay, but I will for sure leave the message there.
All right. Say it again.
She wasn't getting so much when she was uptight.
Yeah, you better look away for it.
What are y'all talking about?